Okay, so today we're going to cover something called the hinge theorem. Now, the hinge theorem builds on what we did last class. That was triangle inequalities in one triangle. The hinge theorem talks about two triangles. So if you read through here, it says, if two sides of a triangle are congruent to two sides of another triangle, the included angle of the first is larger than the included angle of the second. Then the sides opposite the first, or the angle of the first triangle, is larger than the sides opposite of the angle of the second triangle. What does that mean? That means if you look at these two triangles, here are my included sides. Side 1, side 2, included angle is A. Second triangle, side 1, side 2, included angle is D. That means if the measure of angle A is greater than the measure of angle D, then that means side BC, the non-included side, is greater than side EF, the non-included side of the second triangle. So if this angle is bigger than this angle, then this side has to be bigger than this side. Remember, we can't assume anything in geometry, so this is just proving angle bigger, side bigger. Now the converse, if you think back to the logic unit, that was the opposite. So that means if two sides of a triangle are congruent to two sides of another triangle, the side opposite has to be bigger, or the side opposite is bigger in the first triangle than the second triangle, then angle A would be bigger than angle D. So let's put that in writing. If side BC is greater than side EF, then that means the measure of angle A is greater than the measure of angle D. It's basically the opposite of what we just talked about in the hinge theorem. Remember, converse does the opposite. It's flipping it. So when I look at these comparisons towards the bottom, because it gives me these two angles, we're going to say that is included side 1, this is included side 2. Included side 1, included side 2. You can compare them because the sides are measured with the same. Oops, I labeled this wrong. I said it right, but I labeled it wrong. That would be 1, 2, 1, 2. That means in my first triangle, this is bigger than this one. So that means KL has to be greater than PM. This angle is bigger, so this side, oops, can't point right. This side has to be bigger. If I were to do this with colors, because I know this is extremely confusing. If I was going to do this with colors, here's KL in red. Here is PM in green, even though that looks kind of yellow. If I'm looking at these two, this angle is bigger. My dot's going to be bigger, so I can tell that it's bigger than this angle. If this angle is bigger than this angle, this side has to be bigger than this side. Therefore, KL is greater than or bigger than PM. Now, if I were to do that for number 2, it's a little bit more difficult because not both of the sides are labeled as clearly as it was in number 1. Here, this side has to be the same as this side. Same measurements, right? Because this shares a side, that's going to be my other side. So I've got my two sides. Now I have to see what we're comparing. We're comparing AD, which is this side here. We'll make it blue. AD is blue. And we're also looking at BC. We'll make BC red. Now I'm looking at the angles to see which one is bigger. I'm comparing angle 65, angle D, which is 65, with angle B, which is 59. This angle is my blue angle. It's across from that side. Angle D is my red angle. It's across from that side. Now, out of those two, which is bigger? Angle D is bigger. So that means AD is going to be less than BC. This is bigger. Mouth faces the bigger one, in case you forgot inequalities. If I look at number 3, it's really similar to number 2, but I have a problem. So before we get into the problem, let's just label it like we just did. WX can be blue this time. There's WX. And XY is going to be red this time. There's XY. Now, if I'm looking at my sides, the two that are labeled, they're both 3s. That's going to be my second side. And then like in number 2, I'm sharing a side, so that's going to be my first included side. That means my first angle, or my blue angle, is going to be this one that's 53 degrees. But my second angle is going to be this red one. There's no writing in that red one. I don't have a measurement for that yet. But like a triangle, or because it's a triangle, not like a triangle, because it's a triangle, there are 3 angles. That means I could figure out what any one angle is if I have the other 2. I've got 2 measurements for angle Y and angle X. So that means I'm going to say 180 minus 93 minus 32, and that's going to give me the measure of angle Z. If I put that in my calculator, that gives me 55 degrees. We'll write it over here too, so it's a little clearer to see. So because that is 55 degrees, now I can see which one is bigger. Red is bigger, so that means WX is less than XY. Okay, let's try another one. Now, these 3 were all hinge theorems. I'm looking at the sides. Now I'm going to look for my angles. So there we go. Because I'm looking at my angles, I'm looking for the measure of angle D and the measure of angle H. So here in blue is angle D. Here in red is angle H. Now, if I was looking at those, I have to look at the sides around them. Remember, if we're using the converse, that means if one side is greater than the other, then one angle is greater than the other. If I'm looking at the measure of angle D, I have to look at the side that is across from that. Same thing for the measure of angle H, I have to look across from it. Now, if I compare those 2 numbers, what number is bigger, 35 or 33? 35 is bigger, so that means blue wins, and angle D is greater than angle H. Okay, we're going to try 2 more. So here, I'm looking for angle RSQ. When I do this, I'm going to trace around, and whatever angle is my vertex is where I'm going to put my color. So once again, I'm going to start with blue for RSQ, and my vertex is here at S. For angle TQS, my vertex is Q, so I'm going to put my red at Q. Now if I'm finding the sides, I'm going straight across from S, that gives me 13 for QR. And across from Q gives me 14 for ST. Out of those 2, ST is bigger because 14 is bigger. So the mouth opens towards TQS. Okay, I've got 2 final ones. I've got JMK. So first one's still saying blue. Here is my first one at a vertex of angle M. And then my other one is the opposite side of that. It's LMK. So it goes there. If I'm looking at the sides, I'm going directly across. That means 27 is what I'm starting with. Oops, I forgot to highlight this red. 27 is what I was starting with, and 28 is what I'm comparing it to. Out of those 2, 28 is bigger. So there is my inequality symbol. You've got some practice problems over this. Remember, if you have questions about this video, please do ask your teacher.